Good evening, children. Welcome to Akshara IIT Foundation. This is Srinivas, your maths faculty. Let us go to the today's class. In our previous class, we have discussed about the surds, right? What is a surd and its form, and that means types of surds based on the terms and based on the order also we have discussed. So let us check some of the problems based on the surds. Okay. So practice sheet I am going to discuss about. So usually for multiplication of, like while we're discussing about the fractional terms, when you multiply or divide a fractional terms, we are no need to check the similar terms. That means like or unlike, we no need to check. But adding or subtracting the fractions, we should check whether they are in like terms or not. Same way, for the addition and subtraction of surds, we need to check whether they are in the same or similar surds or not, or like surds or similar surds, both are same. Okay, now, so if they are not in the similar surds, we need to convert them into similar. Okay, so let us see the practice sheet problems. Before going to the practice sheet, we know that laws of surds, like nth root a into nth root b. These are maximum like laws of exponents. Okay, na? So nth root a into nth root b we can write as nth root a into b. Okay, in same way nth root a divided by nth root b we can write as nth root a by b. Clear? Yeah, these two mainly you need to remember. And while when discussing about that surd form nth root a, where a is radicand, n is order of the surd, and nth root is symbol of the surd or sign of a surd. Okay, na? Right. And that too, the radicand should not be in the power of its order. For that means cube root 64 is there. If you are taking, it is a surd. To become it is a cube root 64 is a surd, the radicand 64 cannot be a cube number because order is 3, no? So 64 cannot be a cube number, but 64 is a cube number. 4 cube is 64. So it is not a surd, it is a rational number. Okay, na? To express surd form of a number, that radicand should not be power of its order. Okay, right. Let us go to the problems here. Which of the following is a surd? The question number 1 is which of the following is a surd? So first option is 4th root 81. Second option cube root 27, and third option is root over 16, and fourth option is root over 8. So while you are observing, all are looking like in the form of nth root a only, but we need to identify which is the surd. Just now I have discussed about the surd. The radicand in the surd form is not in the form of its order. That means we cannot express the radicand in the form of its order. Okay, na? For example, what is the order here for first option? Order is 4. That means 81 should not be the power of 4. But while you are observing 81, we can write as, let us write 81 in exponential form. Yeah, 3 table here 9 times. 3 table 3 times, 3 table 1 time. So 81 we can express as 3 power 4. What is the order here? Order 4, and 81 exponential form also 3 power 4. So 4th root 81 is not a surd, it is a rational number. Okay, na? Same way, 27 is a cube number or not? Yes, 27 is a cube number. 3 cube, 3 into 3 into 3 is 3 cube. 27 is a 3 cube. And it is cube root. That means order of this surd is 3, and the radicand also we are expressing in the form of 3 powers, means power of 3. So second option is also not a surd, it is a rational number. Next, what is this root over 16? What is the order of this one? Order is 2. That means 16 should not be a square number. Cube root means that radicand should not be a cube number. Square root means that radicand should not be a square number. But 16 is a square number. 4 square value 16. 4 into 4, 16. So root over 16 is also not a surd. It is a rational number. Now coming to root 8. Root 8 we can express as 2 into 2 into 2. That means 8 is nothing but 2 cube. But while you are observing here, the order of the root is 2 but not 3. Order of the root is 2 but not 3. So it is a surd. So our required answer is root 8. Okay? We need to check the order with the exponential form of a radicand. Okay? Let us go to the next problem. Yeah, problem number 2. Now observe here, which of the following is not a surd? Second one is which of the following is not a surd? That means first option is cube root 4. Second option is square root 3. Third option square root 8. And the fourth option cube root 27. Which of the following is not a surd? It is a surd or not? Yeah, cube root radicand is not a cube number. It is a surd. Square root 3. 3 is not a square number. Order 2, because this is order 2. Radicand is not a square number. So it is also a surd. Third one 8. Order 2. It is also not a square number. So it is a surd. Now last one, see. Order 3. 27 is cube number. Because 27 we can express as 3 cube. Okay, na? Exponential form of the radicand is 3 and order also 3. It is not a surd. So this is only our required answer. Okay. Yeah, let us go to the next problem, children. The order of the surd of root 7. Root 7 is nothing but square root 7 or 2 root 7. So order is 2. So we can easily identify order is 2, nothing but quadratic surd. Order 2 surd is called quadratic surd. Okay. Question number 4. Now while you are observing here, 2.7128, 2.7128 and so on is an example of, this is an example of irrational number. How can I say this is an irrational number? See, there is no digit is repeating here and this dots indicates non-terminating decimal. So it is non-terminating, non-repeating decimal is nothing but irrational number. Okay, na? So let us go to the question number 5. Now, radicand of the surd 3 into root 25. Radicand means 25. Okay, no? Radicand is nothing but the number which is placed in the root. It is in the form of nth root here. A is called radicand. Here 25 is called radicand. Okay. So let us go to the question number 6. So an example of a quadratic surd. Quadratic surd means what? Order 2 surd is called quadratic surd. That means it should be in the form of square root 2 or root 2. Both are same. If it is given cube root, this means order 3. Fourth root, order 4. Fifth root, order 5. But you are asking about that quadratic surd. Quadratic surd means nothing but order 2. Order 2 surd is nothing but here root 12. Yes, root 12 is a example for quadratic surd. Among the 4 options, root 12 is an example for quadratic surd. Okay? Yeah, let us go to the next one. Question number which of the following is a mixed surd? I told you the mixed surd, that means a rational number with a quadratic or cubic, whatever. Rational number with a surd and there is no plus or minus symbol, only multiplication symbol between them. Then we can take that mixed surd. Okay, na? So, but the options while you are observing for 7th one, that is cube root 6 and second one is 4th root 16 third one is fourth root 8, and fourth one is 2 into cube root 2. So among them, fourth one is mixed surd. One rational number with a surd is called mixed surd, right? So option 4 is our required answer. Now problem number 8, the simplest form of cube root of 162. Very, very important. Simplest form of cube root of 162. Let us find the prime factors of 162 first. Okay, na? So I am taking 2 table 81 times, 3 table 27, 3 table 9 times, 3 table 3 times, and 3 table 1 time. That means cube root of 162 I can write as 2 into 3 into 3 into 3 into 3. Okay, na? So cube root means among these three same numbers, only one number will come outside. So remaining two being inside. So cube root of 2 into 3, 6. So this is the simplest form of cube root 162. That means 3 into cube root 6. Okay, na? That is our required answer. Check. Next one. The value of fourth root of 1296. Again the value of fourth root of 1296. 1296. So again I am going to find the prime factors of 1296. I am taking 2 table, 2 6s are, 2 4s are 8, 2 8s are 16. Again 2 table, 2 3s, 2 2s, 2 4s. 2 table 16, 162. Again 2 table 81. Here onwards 4 will come. So 3 table 27 times, 3 table 9 times, 3 table 3, 3 table 1 time. So while you are observing, the prime factors having 2 into 2 into 2 into 2, 4 times it is presenting, we can write that 2 power 4. Into 3 also 4 times is presenting, we can write it as 3 power 4. That means fourth root of 2 power 4 into 3 power 4, nothing but 2 into 3 whole power 4. But I am writing this fourth root in the exponential form. It is whole to the power of 1 by 4. 4 4 cancel, 2 3 is 6 will be remains. Okay, na? Our answer, our required answer will be 6. Okay, so let us go to the question number 10. The 10th question, while you are observing the simplest form of square root of 50 by 4. Simplest form of square root of 50 by 4. Okay, so now you can cancel this one as both are cancelled in 2 table here 25 times 2 times. So 25 by 2. So root over 25. 25 is a square number, 5 square root cancel. That means I can write root over 25 by 2 as root 5 by root 2. Sorry, root 25 by root 2. Root 25 value 5. 5 by root 2. I am using the rationalizing factor here. Then root 2 into root 2 becomes 2. This is 5 into root 2 by 2. This is our required answer. Okay, na? So that's it. Going to the next question. Problem number 11. So 11th one, the product of two similar quadratic surds. Product of two similar quadratic surds is rational surd, biquadratic surd, or cubic surd. So I am taking that similar quadratic. If you take any two similar quadratic, their product is always a rational number. So product of two similar quadratic surds. Two similar quadratic surds is rational. Okay, na? So let us take one example here. So example, that is root over 3 into root over 3. Root 3 and root 3. Root 3 into 2 root 3 into root 3. Root 3 similar, like similar surds. So while you are multiplying here, root 3 into root 3 become 3. 2 3s are 6. 6 is a rational number. Okay, na? So from this we can say that product of two similar quadratic surds is a rational number. Problem number 12. Coming to the question number 12, the product of two dissimilar surds. Product of two dissimilar surds is a surd itself. Product of two dissimilar is a surd. Let us take one example here. For example, cube root 2 into root 2. Let us check. I am changing this one cube root 2 as 2 power 1 by 3 and this one 2 power 1 by 2. While you are applying that loss of exponent, if the bases are same, we can add the exponents, right? A power m into a power n is nothing but a power m plus n. Same concept I am applying here. 1 by 3 plus 1 by 2 that equal to 2 power 5 by 6. 5 by 6 is nothing but I can write this 2 power 5 whole power 1 by 6, nothing but 6th root of 32. 6th root of 32 is also a surd, not a rational number. Okay, so product of two dissimilar surds is surd itself. Okay, let us go to the next problem. Problem number 13 itself. That is 4th root of cube root of 3 power 6 value is how much? So we need to discuss here mth root of a is nothing but mnth root of a. This is one of the law of a surd. We should use this surd to simplify here. That means 4 into 3, 12. We can write 12th root of 3 power 6. So 3 power 6 as it is radicand. 12th root we can express as 1 by 12. That means it is in the form of a power n whole power n, a power m into n. So 6 table here 2 times. 3 power 1 by 2 is nothing but square root of 3. 3 power 1 by 2 means square root of 3. Okay, na? That is our required answer. So let us go to the question number 14. The question number 14 is, if A, B, C are a rational numbers, A, B, C are a rational number, then A plus B root 2 plus C into 4th root 2 equals to 0. A, B, C are rational numbers. When the values are become 0, 4th root 2 should become 0 means C value must be 0. Root 2 value, this value should be becomes means B value also 0. A must be 0. Then if A, B, C are zeros, then sum of these three numbers becomes 0. Otherwise there is no chance for us. That is only the option. If A, B, C are zeros, then the entire sum of these three numbers, rational to irrational numbers, rational two surds becomes 0. Okay, na? Question number 15. Sorry, exercise problems now. Let us go to the exercise 1. Okay, so exercise 1 problems. Surd of order 4 is called. Surd of order 4 is called, very good, biquadratic. Surd of order 4 is called biquadratic surd. Okay, na? Next, question number 2. If 3 into 4th root 5, 3 into 4th root 5 is a pure radical, form. That means pure form or pure surd form or pure radical form is nothing but, it should not be in the form of mixed. The 3 must be, in the place of 3, it should be 1. That means we need to carry the 3 inside the surd. Okay, na? How to carry this? That means this is 3 into 4th root 5 is the number is given. This is 4th root. That means we need to take the 3 inside the root. It will be 3 power 4. It will be 3 power 4. That means 3 power 4 into 5. 3 power 4 value how much? 81. 3 into 3 into 3 into 3, 81. 81 into 5. Multiply 4th root of 405 is our required answer. This is the pure form of 3 into 4th root 5. Okay, na? Yeah. So let us go to the question number 3. That is 4th root 3 into 4th root 2. Both are same order. That means we can 4th root 3 into 2. That means 4th root 6. Okay, na? 4th root 3 into 2 is nothing but 4th root 6. That is our required answer. Next, question number 4. The entire form of the surd. Entire form of surd 2 into cube root 5. Entire form are pure surd. Both are same. Again, this 2 we are going to take inside. That means 2 become 2 cube because order 3, you know this one. 2 cube into 5. 2 cube value how much? 8. 8 into 5 is 40. So cube root 40 is our required answer. Let us go to the question number 5. That is, find the, if k plus 1 into 4th root 5. K plus 1 into 4th root 5 is an entire surd, then k value. To become entire side, the quotient before the radical form, quotient before the surd form must be 1. That means it should be 1 means k value becomes 0. If k is equal to 0, then 0 plus 1 becomes 1. 1 into 4th root 5 is entire form or pure surd. Entire surd or pure surd, okay? So k value is 0. Now pure surd of, again pure surd of 2 by 3 into root over 32. 2 by 3, this is square root order 2. That means when you take 2 by 3 inside, it will be order 2. That means square number it should be. Into 32. Let us simplify this. 2 square value 4, 3 square value 9 into 32. There is no cancellation between them. Directly multiply here. 128 by 9. 432s are 128 by 9. That is our required answer. Square root of 128 by 9. Okay. Now 7th one. Let us go to the 7th problem. So that is the simplest form of 5th root 288. Simplest form means we need to convert them into smallest term like mixed terms or mixed surds. Okay. So 288 can be written as product of primes by doing the prime factorization. It is 144. 2 table 72, 2 table 36, 2 table 18, 2 table 9 times and 3 into 3. 3 ones are 3. Here 2 how many times? 5 times. So 5th root 288 we can write as 2 power 5 into 3 square. 2 power 5, that means while we are taking that outside number, rational number to inside, it will be same power according to its order of the surd. Here order of the surd 5, this is 2 power 5, that means 2 will come outside. 5 cancel, 2 into 5th root 3 square value 9 will be remains. This is our required answer. Okay, na? Yeah, let us go to the next question. Problem number 8. So that is, if 5th root of x cube equals to x power y, then we need to find out 4th root of y. First we need to find the value of y. So I am expressing this one in the power of exponents, exponential form. That means this is x power 3 by 5, that is equal to x power y. Compare that one, y value is 3 by 5. So the answer is 4th root of 3 by 5. Okay, no? It is not 6, it is 5. Done. Problem number 9. Check that problem number 9 here. That is, cube root of 4 into cube root of 8 by square root of 4. First two order is same, but denominator order is different. Let me simplify the numerator term. Both are same order, we can multiply. 4 into 8, 32. Now, this one, fourth one is order 2, no? But it should be 3. How to convert them? That means I am changing both of them into the similar surds. Okay, that means order I am going to change. Here order 3, here order 2. Their LCM of 3 and 2 is 6. Okay, now I am writing 32 power 1 by 3. This is 4 power 1 by 2. Exponential form. But LCM is 6, no? I need to convert both of them into 6. That means I multiply with 2 by 2. Here this one I multiply with 3 by 3. Now check here, 32 power 2 ones are 2 by 6. This is 2 by 6 and this is 4 power 3 by 6. Now among them I can write this one 32 power 2 into 1 by 6 and this is 4 power 3 into 1 by 6. this 1 by 6 I can write as 6th root. That means 6th root of 32. This square will be there, no? 32 square by this one 6th root of 4 cube. Now we can directly write this 6th root of 32 square means 32 into 32 by 4 cube value is 4 into 4 into 4. Now try to do the simplification here. (16). So 6th root 16 is our required answer. Okay, na? So let us go to the problem number 10. Yeah, just listen carefully, children, this one. Then you will understand the remaining also. So 4th root of 625 by 9, that equals to root x. We need to find the value of x. But here, what is the order of here root? Order of the root is 2. That means I can do squaring on both sides. I can do squaring on both sides. Squaring on both sides. So before that, let me express this into the exponential form. 4th root means how can we express this? 4th root means whole to the power of 1 by 4. That is equal to, this is square root means whole to the power of 1 by 2. Now what I have written here? Squaring on both sides. Squaring on both sides. Here square and 2 cancel, x power 1 value x itself. Here 2 table in 4 2 times. Nothing but 1 by 2. 1 by 2 whole to the power of 1 by 2 means square root. That means square root of 625 by 9. So I need to find x value now. So 625 I can write as 25 25s, and 9 I can write as 3 into 3. Okay, that is equals to x. So whenever it is order 2, if you having the same numbers 2 times multiply, one number will come without the root. And here 3 and 3 same numbers multiply, one number will come without the root. Nothing but 25 square, 3 square, square root cancel. So x value 25 by 3. Okay, now. Let us go to the next question. Okay, now. Now you join the class. Problem number 11, that is 3 into root 45 minus root 20 plus 7 into root 5. We need to add. So previously we discussed that we can add only similar surd but not dissimilar surds. But these are all dissimilar surds only. Square order 2 only for all of them. But while you are observing here 45, 25, that means all radicands are different numbers. What are the similar surds? Order must be same and the radicand also must be in the same. Then we can consider that are similar surds, like 3 into root 2, 4 root 2, 5 root 2, root 2. These are all similar surds because all are having the order 2 and radicand also 2. Okay, na? Same order with same radicand we are considering as similar surds. But these are all not having same radicands. So let us try to write into the same radicands. So I can write that 45 as 9 5s 45 or 5 9s 45. 9 again I can write as 3 into 3. Okay, na? 5 into 3 into 3, 45. 20 also 5 into, 20 means 5 4s 20, no? 5 into 4 again I can write as 2 into 2. Okay, plus 7 root 5 as it is. Already prime number we cannot write as product of primes. Okay, from these 3, how many 3's are there here? 2 3's are there. From these 3, these 2 3's are 1 3 will come because while you are expressing this one as 3 square, square root cancel, 3 will be remains. And 5 as it is. Here also from these 2's 1, 2 will come outside, 1 will go on with the square. 2 root 5 plus 7 root 5. Now check all of you. Root 5, root 5, root 5. All are root 5s only. Okay, na? Only square root 5. All are having same order with same radicand. These are all similar surds. We can add or subtract. Now 3 into 3, 9. So 9 root 5. Here positive I am writing here. Plus 7 root 5 minus 2 root 5. 9 plus 7 how much? 16. 16 root 5 minus 2 root 5 is 14 root 5. This is our required answer. Okay, now check that. Let us go to the next problem. Problem number 12. This is exercise 112 sum. Practice sheet already completed. Okay. So it is given x value is 3 plus 2 root 2. X value is 3 plus 2 root 2. We need to find x square minus 6x plus 1. Let us find x square value. X square value means x value is 3 plus 2 root 2 whole square. So it is in the form of a plus b whole square formula. A plus b whole square formula what? A square plus b square plus 2ab. A square value 3 square, b square value 2 root 2 whole square plus 2ab. 2 into a value is 3, b value is 2 root 2. Okay, now 3 square, 3 into 3, 9. This square should be applied for both of them. 2 is square value 4 and root over 2 whole square means 2. Root 2 whole square means root 2 into root 2 becomes 2. Next, 2, 3, 6, 6, 2, 12 root 2. Add these two numbers. 9 plus 4, 2 is 8. That means 8 plus 9, 17 plus 12 root 2. So this is x square value. Now let us find 6x value. That means 6 into what is x value? 3 plus 2 root 2. Multiply here. 6 3s are 18 plus 6 2s 12. 12 root 2. 18 plus 12 root 2. Now substitute in the equation this one. X square value we got that is 17 plus 12 root 2. Next minus 6x no. These two symbols I should write with minus because I found only plus 6x value. To find minus value, so it will be minus 18 minus 12 root 2. Minus 18 minus 12 root 2. And last one is 1 plus 1. Okay, na? 17 plus 1, 18. Plus 12 root 2 minus 12 root 2 cancel. Here minus 18. 18 minus 18 value 0. That is our required answer. Okay, na? Check that. Please note that, children. Okay, children. So that's it for today. You can wait for the next class. Physics sir will take the class. So thank you and have a nice day. Bye bye.